All right, so now I want to talk about something called related rates. So here is an illustration of what related rates means. Look at this circle. As I make the radius bigger, the area of the circle gets bigger. But just as like an illustration, if I have x squared plus y squared equals 1, I can do 1, 4, no, I guess I gotta do it this way, 1 x squared plus y squared equals 4, x squared plus y squared equals 9, and so forth. Notice that the radius in each instance here is increasing by 1, but the area of the circle is not increasing by the same amount every time. So here is what is going on here. The area of this circle A is equal to pi times the square of the radius. So imagine, if you would, that, let's see. Imagine, if you would, that the radius of the circle is increasing at a constant rate. I want to see how the area is changing. So let's say dr dt is, I don't know, 5 meters per second. So the derivative of a with respect to t, well, is the derivative with respect to t of pi r squared. But I can do this with the chain rule. I'm taking the derivative of r with respect to t. So I'm going to get 2 pi r times dr dt. Since I said dr dt is 5 meters a second, then this is 10 pi r meters per second. So if r is 3 meters, then you get 30 pi meters squared per second. And if r is 5 meters, you get 50 pi square meters per second. So what's happening here is, as r gets bigger, the change in the area is larger, even if the change in the radius is constant, which is what you see when you look at my illustration. So I increase this at a larger and larger rate, but when the radius is bigger, increasing the radius a little bit increases the area of the circle a lot. Now let's consider a triangle. So let's say that I've got a triangle, and let's say the hypotenuse of the triangle is always 15, and this side is length x and this side is length y. This is a right triangle, so I know that 15 squared is x squared plus y squared. So now what I want to imagine is that, think of this, usually the way I think about this is, think of this as a ladder leaning against a wall. And what's happening is the bottom of the ladder is giving out, so maybe dx dt is 3 feet per second, because it's the bottom of the ladder is moving constantly to the left. So as a consequence of that, the top of the ladder is going to fall downward. And my question is, what is dy dt if x is 12 and y is 9? And just to verify quickly that that's the correct point, 12 squared is 144, 9 squared is 81. So if you add those, you're going to get 225, which is 15 squared. So that obeys the Pythagorean theorem. So if I take the derivative of both sides of this, the derivative of 15 squared is 0. The derivative of x squared is 2x, and the derivative 2x dx dt, and the derivative of y is 2y dy dt, because I'm taking the derivative with respect to time to a different variable than x or y. So now I can plug in the information I know. I know that dx dt is 3, this is 12, this is 9. So I get 0 is 2 times 12 times 3 plus 2 times 9 times dy dt. So that's 0 is 72 plus 18 dy dt. So negative 72 divided by 18 is dy dt, and that number is negative 4 feet per second. So at the instant that this is 12 feet away and this is 9, this is moving to the left 3 and this is moving down 4. Now what happens when x is a little bigger? Let's say what happens if x is 14. Well, then first off, I know that 15 squared is 14 squared plus y squared. So 225 is 196 plus y squared. So y squared is 29, and y is the square root of 29. So putting this all together, let's see, what was the equation? The equation was 0 is 2x dx dt plus 2y dy dt. So that means that I can cancel these 2's, and then I get that dy dt is actually negative x over y times dx dt. So dx dt is 3, so this is negative 14 over the square root of 29 times 3. All right, well, let's see what that is. All right, so I plugged this into a calculator, and I got that it is roughly equal to negative 7.799, so call it negative 7.8 meters or feet per second. So it's speeding up, which makes sense. Let's try one more. So price demand curve. So x is going to be 10,000 minus 3p squared. So as the price goes up, demand goes down. My question is, what is the change in price with respect to x? So how much do I need to change the price by to increase the number of goods sold by 1, essentially? Well, so if I take the derivative of both sides with respect to x, I'm going to get this. So I'm going to get 1 equals negative 6p times dp dx. So negative 1 over 6p is the change in price with respect to x. So whatever the current price is, you decrease it by 1 over 6 times the current price, and that ought to increase demand by 1, using our discussion before about how differentials work.